Good morning, everybody. Hope you're feeling awake. Thank you for coming out and seeing Databases and Dragons. I have a treat for you, a free eye test courtesy of New Relic Legal. I also have my own little legal clause, which is that my discussions about the data stores today are purely my own grouchy ops opinion and does not represent New Relic as a company. Also, most of the advice that I have for you today is best suited for services that run on more than 50 machines or on which more than 150 people work. If you're smaller than that, just use Postgres and go see Gene Kim because he will help you outgrow it. Until then, your focus really needs to be making your application so good that your database is too small for it. All right, now that I've got the right people in the room, let's talk about storage. Your storage is important, and even more so at scale. It's important because even simple things become hard when you're big. Let's say you wanted to chart the performance of our Insights product like we have here. On the left, we have number of requests, and across the bottom, response time for the requests. Pretty straightforward response time histogram, right? Well, Insights is big enough at this point that just to generate that, we have to evaluate 5 billion events, and we did it in 2 seconds. If this sort of chart took a long time, it would be very hard to answer a simple question. That's not where you want to be. You want to be able to answer these questions quickly, and you want to be able to iterate on them. Let's start to slice and dice. And when you've got this much data, you need something strong under it. Your storage is also important because when it fails, your site tends to look like this. Even the biggest, most adept companies are caught falling on their faces when their storage systems die. Keeping those systems healthy is one of the most important jobs in your infrastructure. So how do you pick the right one? Well, every time you commit to one, you're taking a chance. Maybe this technology will grow with us. Maybe it won't. Maybe I can't afford the consulting fees to make it work well. You might as well just roll the dice. But you're an engineer, you want to do something smarter than that. So you read the websites, you try to understand what they're doing. But if you look closely at these things, they don't really tell you that much. They use a lot of buzzwords, cloud, scalable, efficient, but they don't really tell you how good of a fit they are for your product. So at the end of the day, you really are going to have to try it out yourself, and honestly, who has time? It would be awfully nice if we could characterize these things, get some kind of summary of what they're good at, what they're a good fit for, and what they might not be. I know. All right, some of you are going to recognize this, but for those who don't, there's a little bit of backstory. So in tabletop role-playing, players must assume the role of a fictional character. It's a bit like improv. You're given a situation and something your character cares about, and you play it out in a group under the guidance of another player called the Dungeon Master. Now, role-playing is a lot more complex than an improv sketch. So people use these things called character sheets. Across the top is the name and some basic information about the character. On the left and center, some stats about how good they are in combat, how intelligent they are, how charismatic. And on the right side, some little personality descriptions to help you understand what this thing is about. Well, what if we could build one of these for our data stores? It might help us build an idea of what these things are good for. So when you're trying to characterize your data, here are some questions to help you do that. Now, remember, we want to find a storage system that will fit your data, not the other way around. What you don't want to do is go on Hacker News and find something that sounds cool and start rolling that into production. You're going to have a bad time. Answers to questions like what type, how much, and how structured the data is can start to give a picture of what it is you're really working with. We'll spend almost all our time today on the type. Most data stores are a good fit for one type of data or another, and the question of type usually answers some of those other questions for you. Now, in tabletop role-playing, there are types for characters too. When you're building a character to play, the first thing you select is the race or species. Most games have about a dozen races, based in fantasy tropes like elves, dwarves, and the like. So we'll pick some races for our different data types, just so we can put a face on these things, and maybe the game lore will tell us a little bit about what they're like. We'll start with event data. Very basic data type. Something happened, we have a record of it. Here I've given it the human race. In the role-playing lore, it's a very flexible class, has the shortest lifespan, good at lots of things. This kind of data is common in monitoring systems, ad tech, analytics. Very, very commonly seen. Not all data stores treat it like a first-class thing, but you're almost always going to work with it somehow. Again, in role-playing, the next thing you pick when you're building your character is a class or job. Each race has some classes or jobs that they're a good fit for, and some they're not. So, for example, if you want to play a magic-using class, you should pick a magic-using race. So let's pick a class of data store for our species of data. This brings us to Insights, represented here by the human fighter. This should remind you of the character sheet we saw earlier. Got some personality descriptions on the left, and for comedy, some stats on the right. This is a versatile, adaptable data store, no major weaknesses. It has some issues around large data, so if you have a very big event, you probably shouldn't use it. But if you have a very fast stream of smallish events that you want to query any way you want, it's going to get you there. If you prefer something non-commercial, we've had good luck with Graphite, Elasticsearch, and InfluxDB. These are going to require more work from you to make them get going, but you get to run it yourself, and sometimes that's important. Not all event data is discrete. Sometimes you can summarize a series of events over a period of time. That's time slice data. Sometimes a summary is enough. And the reason you would do that is because you can store hundreds of times more data as a summary than by storing every event. You can't get the individual events back once they're stored in this kind of system, but again, often that's fine. You can get the average, you can get the max, you can get the min. You might see this kind of data in weather or scientific observations, anywhere where the overall view of it is plenty. Cassandra is a great fit for this kind of data. I've classified it as the Bard because it always needs supporting characters around it. There's a couple out there for time series data specifically, one called KairosDB and another one from Dell called Doratus. These form a layer that understands time series data natively on top of the Cassandra storage backend. For smaller volumes of time series data, you can probably just use Graphite. The best thing about Cassandra for this use case is its extreme scalability. When you need to store a lot of time series data, you're going to outgrow Graphite, you're going to run it on a big server with a whole lot of SSDs. It's not very fun. With Cassandra, you just scale it out. This is relational data. Almost everyone has some kind of relational data somewhere. This is a typical SQL database, your MySQLs, your Postgres's of the world. Like the elf here, SQL loves to build ornate, complex data structures that'll live forever. If you have financial, medical, or auditing records, any kind of PII data, this is the kind of system that's going to care for them. For this, we come back to Postgres. Like the wizard here, Postgres is a really powerful database, always acting within constraints on its behavior. Probably not your first choice for machine-generated data, but that's OK, because you're almost always going to need one part of your system or another, one data store, one feature, one component that needs this level of consistency and durability. If your answers to the questions about how big and how fast are things like tens of terabytes and tens of gigabits, then you're probably going to need something else to support this. But if your answers to questions about structure and consistency are incredibly and perfectly, you're going to need Postgres somewhere. Another very common type, binary and blob data. I've represented it with the dwarf here in game lore. A very conservative and flexible race likes to build big underground civilizations. Anybody dealing with user-generated content, images, videos, documents, this sort of thing is going to be working with binary data. It tends to specialize based on the type of binary data. So if you have systems that are really, if you have systems that are specializing in images, they're going to understand a lot about images, and putting a video in there isn't going to work as well. Best place to put this data is S3. Like the Paladin here, it's a very principled system. Stores blobs. It's got a little bit of magic around how it's, keeps them durable and moves them around the world for their availability. But mostly it's about the blobs. So the pattern tends to be you store the file in S3 and the metadata, for example, in images, the width, the height, the format, in a different system like an event store or a SQL store. You wouldn't store the whole file in the database. That kind of ends up bad. So you store the address to it in S3 in the database. Now, with any data store, you're going to find some optimization that would be helpful, but which can't be applied directly in the system. So you might enter a caching system. Excuse me. You might come up with some tool like a cache to put on the side and help improvement. So here's the gnomes. Gnomes are inveterate tinkerers, always coming up with some tool to improve things. I recommend two different caching solutions, one more structured and one more scalable. We'll start with the structured one. This is Redis. It's good at things like sets and hashes and atomic counters, disarming concurrency traps that can get you in trouble, hence its class of thief. It is pretty small scale. You're going to need something bigger to support it when the scale gets big. Pair this up with a half orc, and you're going to have a pretty powerful structure. At some point, you will probably outgrow it if you're using it for a very large system. It scales to about a single machine. It has replicas for failover, but it's not natively clustered. If and when you outgrow Redis, you want to use Memcache, a more versatile system in terms of scale, but much less structured. Like the Ranger, it's very adaptable. A lot of systems can use it in a lot of different ways. It's pure key value, though. No data types other than strings and counters. If you want to get structure into it, you can serialize it into string. Historically, it's had really poor persistence. It won't actually write to disk. It doesn't necessarily have replication. For those things, you can pair it with a product called McRouter, come out of Facebook about last year. It will do replication on top of Memcache, so you speak to your McRouter instance and it goes down to Memcache, and you can set up more complex structures with it. So there are some options for different data types. When you're thinking about how to use these, remember, production is a chaotic place. Reality is a real jerk of a dungeon master. Your data store has to withstand a lot of chaos when it faces your users, so they need to form a strong partnership. A party, if you will. See, in tabletop role-playing, you never play alone. You work alongside the other players to form a party of characters that bring their specialties to the fight. So what does it look like to form an effective party? You should start by picking characters that compensate for the other's weaknesses. If you already have a SQL database and you know you're going to scale to get a lot of collected data, you should add something that specializes in data collection. If you already have a cache system and you need something that's bigger and simpler, you should add one that does that. You should pick characters that are well suited to their tasks. You should try not to adapt a SQL storage for storing binary data. It's just not what it's meant to do. It would probably be better to pick something that's designed for that. Finally, you should pick characters you understand. If you need a SQL database and you hate Postgres and you've spent 10 years with MySQL, just use MySQL and know what it's good for. You're going to need to understand these systems to think like them, to inhabit the way that they see the world, if you're going to help it grow to be big enough to serve your product and serve your users well. Here's an example. These are some features from our synthetics product, time series, trace, and configuration data, respectively. They're storing these in insights backed by NRDB, S3, and Postgres, represented here by the human fighter, dwarf paladin, and elf wizard, which, if you've been role-playing, makes a pretty strong party. So by picking these data stores that are so well suited for their purpose, the synthetics product gains some big advantages. They can spend more engineering time on what's unique about their product and much less on what's interesting about storing time series data. Their individual features are very resilient and isolated from failure because they run in completely separate systems. And they can scale them independently. If they were to release a feature that involved recording much more time series data, there's only one of the systems that would need to get bigger, and the others could be left alone in a stable state. We've spent a lot of time talking about what type of data you might have and some services that'll be a good fit, but that's just a start. You should spend time on these other questions too. They will get answered eventually, either by you or by your users. You may find issues of scale and structure make one of the systems I've covered today a poor fit, or that your application is so radically different that you need something completely otherworldly. But you need to do your research and think about the type and what it's suited for. So by picking proven data stores suited to your service and its needs, you can be equipped to face the chaos of production. By picking ones that complement one another, you can scale quickly and stay available. So go forth, form your party, and ship a great service. We have a few minutes for questions. There are 2 microphones set up, one in each aisle. Please come up to the microphone and ask your question. I would love to have someone, ask me what I had for breakfast, for heaven's sake.
He's super nice.
Wonder why I didn't pick MySQL or why I didn't pick your favorite storage system. Yes?
Hey, if for some reason you're living in the dark ages and not in the cloud yet, do you have recommendations for binary data besides S3?
OK, so I don't know that space as well in terms of on-prem. I've had the luxury of being able to use S3 in most contexts. I've heard good things about Cinder, which is the OpenStack binary storage system for on-prem. And then there are, I'm totally forgetting the names, but I would love to hook up with you afterwards. There are systems that run on top of Cassandra that use it as the backing store for blobs, much like Kairos DB for time series. There's a hand being raised. Please come up to the microphone if you have something to say. Yes.
I think you mean Swift.
Swift?
That's the object store.
Oh, OK. You'll forgive me, there are very many projects in OpenStack.
No, right.
What does Cinder do, out of curiosity?
That's the block storage project for
block storage. Yeah. Thank you.
It's really easy to ask a question after a speaker gets something wrong. I personally feel a lot more comfortable asking questions. You can't go wrong there. Come on.
Yes.
Actually, I did have a question. I was kind of curious. As far as when you actually do the ingest of data, do you guys use Cassandra, to sort of store some of that, or are you using DynamoDB? Do you know, can you share some of that sort of like magic?
We use a variety of systems depending on the product. NRDB handles a lot of data. MySQL handles quite a bit as well. We have some products that use Cassandra. That'd be something I'd love to talk to you after if there's a specific question you have.
Well, the event types, because I was kind of looking at, you were kind of characterizing that. I was kind of curious about, what would kind of constitute as. You mentioned Cassandra, but I was kind of wondering if DynamoDB is sort of like in that same area.
We do use a little bit of DynamoDB, but it's not for any of the time series data that we have. But it can be used for that pretty well.
Okay.
Yeah.
What's better in your opinion?
You didn't mention performance particularly as a criteria. It was lower down, but there's the in-memory databases coming out now, which are 30 times faster things. Do you want to talk about that a bit?
Yeah, in-memory databases are great times. Most applications have to write to disk somewhere. If you have a system that has a really short retention period for your data, or where availability or failover is not that important, in-memory can work really well. You will sometimes see that in FinServ, where they have just throughput is king, or AdTech, where they have to have this stuff available and really, really fast all the time. Redis works is, I think, a good fit there as well. It's kind of got a little bit of both. They have their place. I don't know that there's a type of data that I can make a recommendation, say you should put this in an in-memory database. You usually sort of get backed into an in-memory database. Does that answer your question there? Cool. And then to your question about whether I prefer Dynamo or Cassandra, I think that one comes down to whether you need to use it yourself or whether you can get away with just paying for Dynamo. That seems to decide those issues because their data structures do tend to be similar enough that you can typically use one or the other. Yes?
So my question is, just to give you an example in my situation, we have very large amounts of data with very mixed loads. So when you say storage is king, I'm curious on the database side how you handle large amounts of data that have very different patterns.
Well, if you can get away with it, you should put them in different data stores. That seems to be kind of our experience so far has been when you have a type of data that behaves a certain way, you should try to put it in a system that's good for that and avoid mixing. If you have one type of data that is a high throughput steady state stream and another type that's very bursty, you should try to isolate those systems from each other.
Okay, cool, thank you.
You're welcome. Yes?
Yeah, just to expand on that, you've focused on using the right tool for the right job. Can you expand on any challenges where you have to have these different tools work together well, and maybe it's nice for one tool to kind of know how data is stored in another tool?
Yeah, so the pattern we've employed to great success so far has been to have a service own its data. So to the extent that you can have systems that own their own data behind them, and other systems that need to work with that data only talk to the service fronting it, you can win because you control access to the data. And if there's a behavior that another service needs to understand about that system, it just needs to understand it at the service interface level and not at the data structure level. So inter-service communication is a big win there. And the other one is that a service that owns its own data is very flexible in what it can do with it. You could switch out the entire backend and have other services not care, which is very, very powerful. You don't want to be in a world where any one service needs to communicate with 4 other data types and 4 other databases and needs to understand their schemas. It quickly turns into a Death Star architecture diagram really fast, except you can't move anything. Everything, the lines are set in stone. So have services that front it. That's a very important point. Thank you.
Got time for maybe a few more questions? Any more brave souls? I see people moving.
Yes?
Can you talk a little bit about some of the advantages of a time series database, a database that's built specifically for time series data?
As opposed to one that is like general purpose? Or?
Yeah.
Okay.
Just some of the tools and some of the features of those databases that help you
Yeah.
When you're storing time series.
So with time series data, it's got a really, really specific set of behaviors. It comes in at a high rate. It comes in at a steady rate. It's got a certain resolution to it. It's going to be queried over a time window, and it's going to expire at a given time. A lot of data stores aren't really designed for that kind of flow. If you can do that in, for example, Postgres, but the assumptions that Postgres makes about the world tend to be that the data that you put into it is going to be there either forever or until someone deletes it at a random time. And the ability to, for example, automatically age out data or design it around, always being queried over a time window has to be written on top of it. Cassandra, for example, and one of the reasons I recommend it, has TTLs built into the system as a first-class object. So when you write data into it, you can tell Cassandra, this should only live for a month or a year or 6 months, and it'll just sort of take care of it for you. It's not free, but it's a first-class operation. It also does range queries natively, so when you have a row in the system that has timestamps, you can say, give me the cells of data from this time to that time, and it's just a single scan off the disk. So it's extremely efficient to do that. It understands that that thing is linear. So there's some important behaviors there, and having more of those things be first class in your system gives you more leverage to actually do interesting things with your product than just store time series data. Yes?
I'm curious about queues and how you might use them in conjunction with.
So if you watch Matthew and Nick's talk about our Kafka system, Kafka is a great queue. We've been extremely happy with it. You can use other systems for queues. The most common small-scale queue that I've worked with is Redis. It's pretty darn good for that as well. But if you want something with like multiple consumers, or you want to be at big scale, or have any kind of persistent story that's for real, Kafka is the way to go.
We've got time for maybe one more question, unless you all really want to go to a break 3 minutes early. Anybody? I hear giggles, so I'm assuming that's a yes. All right, well, wait.
One.
Microphone right behind you, if you wouldn't mind.
Thank you.
You mentioned you're using Kafka.
Yes.
Do you have any issues related to encryption in using Kafka? Because it seems like something I don't know if they've fully enabled SSL for all that.
Are you thinking about encryption from transport or storage?
As far as just people, the systems that would publish to it and subscribe to it.
Right. So the question is, do we do transport encryption in and out of Kafka? So our Kafka system sits behind our SSL termination, and all the systems that communicate with it, for the most part, are either within a VPN or within the firewall. So we haven't actually had to set up transport security in Kafka. So I'm afraid I don't actually know.
That was a fast question. I think
All right.
that one would be longer. It sounded like so complicated to me. I do web, so I'm like, this is so cool. Any other questions? Well, I do.
Last question.
Yes.
One more question. So let's say you build something with a key value store and you realize, oh shoot, like this wasn't the right tool. Can you talk about, like, have you run into problems where you have to migrate that to a different, like, relational database, or?
That's not something I've done, but I would love to talk to you about it. That sounds hard. And I think, to that point, this is why spending time thinking about the type up front is important. Like if you thought that it was one type and then it's another, yeah, it's a bummer.
Thanks.
But I'll be up here for questions afterwards. By all means, come up and argue about which data store is best. Love to talk.
There's no arguing. There's gentle conversation.
Discuss.
And hushed, reverent tones. All right, so big round of applause for Jonathan, everybody. Thank you so much.